Hi everyone, we are Inspired Team from Lanang, and we believe that the future of energy shouldn't be expensive or harmful to the earth. Through this video, we explore how we can use smart chemistry to solve real-world power shortage. We are specifically looking at how rural communities like those in Borneo can turn agricultural waste and simple salt water into reliable energy.
By using redox reaction, we can transform trash into a sustainable power source.
Every day, we throw away energy, not just waste, but power we never use. What if your trash could turn the lights on? This light doesn't run on electricity. It runs on waste.
Today, the world is rapidly shifting toward electric vehicles, smartphones, and renewable energy. But there is one major challenge: storing that energy. Most modern batteries rely on lithium. However, lithium is expensive, limited, and its mining process harms the environment. As global energy demand continues to grow, we are facing a more critical question. Can we find a solution that is affordable, sustainable, and locally available? Now, instead of relying on expensive lithium, scientists are exploring alternative solutions, such as saltwater batteries and biobatteries. These batteries use natural and easily available materials. In regions like Borneo, agricultural waste such as banana peels and rice husks can be transformed into useful energy materials. Waste is no longer waste, it becomes power.
To answer this question, we turn to chemistry. A battery works through something called a redox reaction. Redox stands for reduction and oxidation. Oxidation is the loss of electrons, while reduction is the gain of electrons. When electrons move from one material to another, they create an electric current, and that is what powers our devices. In simple terms, a battery is a system that allows electrons to flow, and that flow gives us energy. For example, a car battery, specifically a lead-acid battery, operates as a galvanic cell that converts chemical energy into electrical energy through a continuous cycle of redox reactions. Anode is made of lead. Cathode is made of lead dioxide. Electrolyte is a solution of sulfuric acid and water. The lead atoms react with the sulfate ions in the electrolyte. During this process, each lead atom loses 2 electrons to become lead sulfate. These lost electrons flow out of the negative terminal through the car's electrical system and back to the positive terminal. This flow is the electric current. The lead dioxide reacts with the sulfate ions and hydrogen ions in the acid. It accepts the electrons coming from the anode, transforming the lead dioxide into lead sulfate and water. As long as there is lead dioxide and acid available, the battery can supply energy. Most of the batteries recently are powerful, but they rely on heavy lead and placed in a highly corrosive electrolyte called sulfuric acid. Sulfuric acid is dangerous to handle in rural homes and can cause severe environmental pollution. Our backyard biobattery uses the exact same as chemistry, the redox reaction, but with a safer twist. We replace dangerous acid with simple salt water, just like in a car battery. The salt ions act as a bridge that allows energy to flow safely. In chemistry, a redox reaction has 2 parts: oxidation, where a material loses electrons, and reduction, where it gains them. In our backyard biobattery, the carbonized waste releases electrons that travel through the salt water to create a steady electric current. Basically, we've taken the complex, heavy, and hazardous components of an ordinary battery and replaced them with biotrash and just table salt. This makes energy not just affordable, but truly accessible for everyone.
But how does this actually work? Organic waste can be processed into carbon-based mixture, which acts as electrodes in a battery. At the same time, salt water can be used as an electrolyte, a medium that allows ions to move between the electrodes. When these components are combined, they can create a safe and sustainable battery system. Simple materials, smart chemistry, new energy.
Now imagine the solution applied in a real village. During the day, the solar panels collect energy from the sun. This energy is stored in biobatteries made from local materials. At night, this stored energy powers home, lights our street, and supports the education. This creates energy independence, reduces costs, and protects the environment at the same time. So teacher, what difficulties do teachers face when teaching redox reaction?
Well, some students they are weak in understanding the concept of redox reaction, but after several explanation, they manage finally.
The future of energy does not have to be expensive or complicated. Sometimes the most powerful solutions are already around us. We just need the science to unlock them. This is not only about innovations, but also about responsibility to our planet and future generations. Even small ideas, when applied with chemistry and creativity, can create real global impact. Thank you.